Alright, so on this problem we are asked to factor f of x equals 3x cubed plus x squared minus 82x plus 120 into linear factors given that negative 6 is a 0 of f of x. Now one thing that we need to note is this theorem here. It says let f of x be a polynomial function. Now if k is a 0 of f of x, you know that x minus k is a factor of f of x, and vice versa. If x minus k is a factor of f of x, then k is a 0. Right? So based on this, we already know one factor for this polynomial function here, and it's x minus negative 6, which is x plus 6. Now, if we use synthetic division using this negative 6, which we know is a 0, right, we should get remainder 0, and then we'll have our coefficients for the quotient, and the quotient will be quadratic, and so then we'll be left with a quadratic expression that we can then factor, and so then we'll have our 3 linear factors for this third degree polynomial function, right? So let's set up our synthetic division. All right, so we have f of x equals 3x cubed plus x squared minus 82x plus 120. So I'm going to write down these coefficients. All right, so the coefficient of x cubed is 3. The coefficient of x squared is positive 1. The coefficient of x is negative 82. And the constant term is positive 120. And so the number that they gave us that is a 0 is negative 6. And so we're going to do synthetic division, and we know the remainder should be 0. So I'm going to do the synthetic division. We'll bring this 3 straight down. Now we're going to multiply. Negative 6 times 3 is negative 18. Now we're going to add 1 plus negative 18 is negative 17. All right, so now we've got negative 6 times negative 17, which is going to be positive. It's going to be 102. So now negative 82 plus 102 is positive 20. Now negative 6 times positive 20 is negative 120. 120 plus negative 120 is 0, which is our remainder. I like to block off the remainder so I can clearly see which one's my remainder and what are the coefficients of our quotient. And again, since we started with a third degree polynomial, once we perform synthetic division, our quotient degree will go down by 1, so our quotient will be degree 2, or will be quadratic. Right? So this quotient here, I'm going to write it out. This is the coefficient of x squared, so we got 3x squared, and that's a minus 17x, and then plus 20. Right? So what we have here is we know one linear factor, x minus negative 6, or x plus 6, and now we know the second factor, which is quadratic, right? We need to factor until we have linear factors, and so all that's left to do is factor this quadratic quotient here. So again, I'm going to go ahead and start to factor f of x. Again, we've got x minus the negative 6, which was a 0, times our quotient, which was 3x squared minus 17x plus 20. All right, so again, I'm going to rewrite that as x plus 6. Now we need to factor the quadratic expression, 3x squared minus 17x plus 20. Now you may use a bottoms-up method. That's fine. I'm just going to factor here using trial and error because the coefficient of x squared is not 1, it is 3. So I'm going to do trial and error. Now one thing I know for sure, again, this is going to it's going to factor into 2 linear factors. Now the first term of each of these factors, they have to multiply to be the 3x squared. The only positive whole numbers that multiply to be 3 or 3 and 1. So I know one of these is going to be 3x. The other one's going to have to be 1x. Now, I know the last terms in each one of those factors have to multiply to be the positive 20. Now, again, we got several possibilities there. Again, they have to have the same sign in order to multiply to be positive. It's going to be 1 and 20, 2 and 10, or 4 and 5. And again, don't necessarily know which of these is going to work. We're just going to pick one, try it, pull it back out, and see if it is correct. Right? Because the leading coefficient is not 1, they will not add to be that coefficient of x negative 17. All right, so let's see. So we could do 1 and 20. Let's try 1 and 20. So again, they need to have the same sign. I don't think 1 and 20 is going to work. Let's see. Let's do 2 and 10. I don't think it's going to work. Let's do 4 and 5. So let's do a minus 5 here and a minus 4 here. And again, I've factored so many quadratic expressions in my life, I can kind of tell what's going to end up working before I try it. So, but what I'm going to do now, just to make sure that this is correct, I'm going to multiply those two factors back together to make sure it's 3x squared minus 17x plus 20. So if we do that, if I multiply the 3x times 3x, that's 3x squared. 3x times negative 4 is negative 12x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. And we can see if we were to combine the like terms there in the middle, we would get the negative 17x. So that is the correct factorization. Now again, with factoring, you know, our operation here is multiplication. Order does not matter. So you can have these three factors written in any order that you would like. Right, but the three linear factors, x plus 6, 3x minus 5, and x minus 4.